I'm going to try to prove a topological identity. For any set, the interior of the closure of A is equal to the interior of the closure of the interior of the closure of A. Okay? So because it's too much work, I just don't write A. And we end up with interior of the closure is equal to the interior of the closure of the interior of the closure. Okay? So how do we prove this? Well, what we're saying here is that the interior of the closure of this thing is equal to this thing. Okay? So the interior of closure of something is equal to that something. So what we're going to do is just work from that left member, from that something. And we're going to grow it. The interior of the closure is obviously going to be included in its closure. So in the closure of the interior of the closure. Okay. Now let's work this member. We can make it bigger because we want to relate it to a certain closure. Okay, so this is going to be included in the closure of the identity. We substitute the interior by an identity, and of course the closure of something smaller is going to be smaller than the closure of something bigger. So here we substitute by the identity. The closure of the identity of the closure, this is just equal to the closure of the closure, which is just equal to the closure. Okay, so let's leave it again, but just write the important parts. This thing here is just a closure, so let's ignore the rest. Okay. We have this. And now what can we do? Now we could, well, if we apply the interior to this inequality, we're going to end up with interior of the closure and the interior of the closure here. So we're going to obtain an equality. And now it's pretty obvious. And so the interior of the interior is just interior. So this is interior of the closure. Is included in the interior of the closure, or the interior of the closure, which is included in the interior of the closure, right? I just applied the interior to all the members, and that's it. That's all we wanted, because we just wrote A is included in B, which is included in A. Therefore, A equals B. Okay. Therefore, the interior of the closure is equal to the interior of the closure, the interior of the closure. That's it. That's what we wanted to prove. And we're done. If there's any need to clarify, in this part, what I just did is nothing complicated. So we have that here, obviously the interior of the closure. So the interior of A is smaller than interior of and then A. Therefore, the interior of the closure is smaller than the closure. Okay. And the closure of, if A is bigger than smaller than B, then the closure of A is smaller than the closure of B. And therefore, applying this here, we just get that the closure of the interior of the closure is smaller than the closure of the closure, which is just closure. Okay, that's all that happened here. Okay, that's it.